Okay, Casey, we can get going. Let's see. Okay, everyone, we're gonna get going. And we have some people on Zoom as well, so we'll try to keep it quieter in here than perhaps we normally do. So everyone here and on Zoom land, welcome to Shoals Marine Lab and our weekly marine seminar marine science seminar. And this year we are live from the island. This is the first time we've done it in this hybrid format. So we are working it out today. Thank you, Sarah. I'm Dr. Jennifer Seavey, the executive director here, and every summer we gather our whole island community and those of you on Zoom to do these weekly talks. So tonight our format is 45 minutes of presentation followed by 15 minutes of Q&A. If you're here, you're going to raise your hand and Sarah will call on you, and I will be monitoring the Q&A that's on the webinar. So if you have a question along the way, please use that Q&A button at the bottom of the screen. Put your questions in there, and then I will ask Sarah. And Sarah, if you don't mind saying them out loud again so everyone can hear it. So our speaker is Sara Morris, and Dr. Morris is the Vice President for Academic Affairs and a professor of biology at Canisius College. She has a master's and a PhD in zoology from Cornell. Do you have 3 undergraduate degrees?
3
Biology, French, and fine arts. That sounds like 3 me. From Presbyterian College of South Carolina. She's an overachiever. You fell in love with birds at age 7, banded your first bird at age 14, and she pretty much hasn't stopped since. And her specialty is songbird migration, and she focuses on topics like the timing of migration, how different species of warblers all work together in migration, which I find fascinating, the spatial distribution of migration patterns, and a lot more that you're going to hear about tonight when she talks about the Appledore Island Migration Station and all of the amazing work that is done here on the island and beyond. So Sarah, you're up.
Thanks, Jen. Good evening. Welcome for those that are here on Appledore. This feels very weird to have the microphone and see all of you actually physically in person. So what I thought I would do today is to kind of share some of the broad things that we have seen from the Appledore Island Migration Station, which is a long-term migration monitoring station. And we have had the wonderful fortune of being able to I've been out here for more than 30 years. The station actually started before me, and that gives us the opportunity to look at things over a broad temporal scale, as well as having a variety of different questions that we can ask. And so we are still trying some of the technology. Nope, it's advancing this one, not that one. Yep, so we're still working on the double screen issues and trying to be able to do this. And again, I can't get to the,
oh, right.
We're still seeing, we can see it here, but not. Which one is advanced?
Go down, right? One more, right there. What is that? That's not helpful. Advanced is at the very top, but are you going to be able to do that every time? You see the very top of that menu? Right there.
That one?
Yeah.
Well, we can try it.
Okay.
It'd be, yeah, let's try. So I'm still trying to figure out how to be able to advance so that we can do that without having to do that every single time. I do want to pay homage to 2 people that we lost in the last 12 months. And the first one, the one on the left, is J.B. Heiser. He is the longtime director of the Shoals Marine Lab. If you came out on the boat this year, you were riding on the J.B. Heiser. The name sounds kind of familiar, and it was kind of named for him. When I was a first-year graduate student at Cornell, I heard a mammalogy lecture by JB, who was talking about everything that was so cool about the marine mammals and here on the Isles of Shoals. And I marched into his office and said, I would love to do a master's on marine mammals and then maybe do my PhD on birds. I have a love of birds. And he said, no, I don't need anybody to do marine mammals. I need somebody who's a bird bander. And if you already heard Jen say that I had been banding birds since the age of 14, I said, well, I happen to have a license. And the very first time that I came out onto this island, the person on the right, Mary Wright, actually W-R-I, Mary Wright was on the island, and she was one of the first people that helped me condition myself to Appledore Island, and she passed away last summer. The picture in the center is me at age 23, and Mary, I'm not quite sure, and I wouldn't guess for that one, where she was basically watching to make sure that I didn't cut off my fingers when I was using the table saw on the island. So long history of doing interesting things on the island. She was helping to set up some of the research projects that we got going, looking at stopover ecology. Well, when I talked to JB about doing some work out on Appledore, there had already been about 10 years of banding that had been occurring. It had started in the late 70s and as an occasional like weekend. And then in fall of 81, they started banding on a regular basis, and they did not have anyone with a license starting in 1990. Well, when I was in middle school and then later in high school, I went down to the coast of Georgia and banded on an island off the coast of Georgia. And one of the things that I had noticed there were these amazing congregations of swallows. The swallows, particular tree swallows, would go down to the coast of Georgia and feed on bayberries, and you would see these numbers increase and increase and increase, and then all of a sudden they would disappear. Well, apparently I was not the first person that noticed that, because this is a 17th century woodcut. And if you notice in here, the ice fishermen have thrown their net in and are pulling out of the water down at the bottom, fish, 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 fish. And then in the middle and at the top, it's bird, 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 bird. They noticed that birds would all of a sudden, they would congregate over these marshy areas. They would disappear. Clearly they were hibernating. That's wrong. They do not hibernate, but migration has been noted and noticed for an extended period of time. As recently as the middle of last century, one of the other misconceptions about bird migration was how far birds could fly. We had no idea some of the capacity of birds to do some absolutely amazing feats. And so some of the research that was being done on flight distances suggested that the ruby-throated hummingbird, and I can do this for the ones in the room, but can't even do that for the ones there. If you look at the blue area where the birds are wintering and the orangish area where the birds are summering, they either are going around the Gulf of Mexico or they're going over the Gulf of Mexico. None of the banding stations in that yellow area were really catching the birds during the fall migration. And so there was a lot of discussion of these birds must be flying over the Gulf of Mexico, but their flight ranges suggested they could only fly halfway. So they were hitching the ride on the back of bigger birds to get across the Gulf of Mexico. That too did not happen. These birds are actually flying across the Gulf of Mexico. So if we think about migration, there's a lot of question about why would you want to study migration? What can you see? How much can you learn? And we know that migration is extremely common among North American birds. Birds across the world, about 20% migrate. Birds in North America, about 70 to 80% migrate. Most North American birds are migrating, at least in some part of their range. There's over half of the species migrate, over 70% of the individuals are migrating. So migration is everything from Atlantic puffins to, just so that you'll know, Atlantic puffin, yellow-bellied sapsucker, Philadelphia vireo, Blackburnian warbler, eastern kingbird, Baltimore oriole, and the one up at the top is an Arctic tern. So lots of different species across different taxa, species that are land birds. I threw in the puffin and the tern because this is the marine station, and I felt like I needed to have at least one or two birds in here that were more marine-based birds. But most of what I'm going to be talking about are land birds. So if you look at this map, what it's showing is, I think it's 118 different species of birds. It goes through the year. You can watch kind of the average of movement up north, and then they turn back around and they start migrating south. And one of the things you may notice is that they actually don't spend that much time up in those northern areas. They're moving back south very, very quickly. It'll flip back around, do it one more time. And so as you watch, the birds will spend a fair amount of time moving around there, then they'll start moving a little bit further north, then they'll take a while, they'll move into North America, they move further north, maybe up into Canada, hang out for a relatively short period of time, and almost immediately start turning back around. So for me, that's always been a really interesting thing, because it's really thinking about birds having, our birds that we think of are really spending more of their time away from us rather than with us. We know that most North American birds, or many species of North American birds, are in decline. There have been some recent studies that say a third of the birds that used to be, a third of the population size of birds has been lost. We're down to about 67% of the birds that we had just a couple of decades ago. And so we know that this is important for our birds to be able to conserve them. We need to know more about what they're doing in their breeding grounds, what they're doing on their wintering grounds, and then what they're doing in migration. They're really not birds of two worlds. They're birds of three worlds, or you might actually think of them as they're birds of 50 worlds, because they have to make a whole bunch of different stops as they're moving between their wintering grounds and their breeding grounds. We know that migration is extremely costly. There are some estimates that suggest that survival of birds is less than 50% on an annual basis, and that most of that is occurring during migration, and much of that occurs in the bird's first migration. So if you look, 99% of the birds will survive during the summer, I think it's about 97 in the winter, but most of the mortality is happening during the migratory seasons. Here on Appledore, or in North America in general, we talk about migrant birds being either short distance migrants, meaning they spend both their summer and their wintering times in North America. They might be in the United States entirely. They might move between the United States and Canada. And then we talk about many of our birds being neotropical migrants. And that's the group that I focus on here on Appledore, primarily because of timing. The Nearctic migrants are moving through earlier than we are able to get on island. They move through later in the fall than we are able to stay on the island. So we're going to focus on neotropical migrants, and I'm going to talk a little bit about some of the history of the banding station and some of the things that we've studied. So for those of you that are familiar, this is Appledore Island, and that is some of my bird crew that have been helping, and I need to make sure that I acknowledge the number of people who have helped along the years. Our research projects involve bird banding. So we have nets. The folks on the island, if y'all haven't been down to the station yet, you will be seeing this tomorrow. The nets have been in pretty much the same places since the 1980s, and that provides our ability to look at long-term monitoring of a variety of different things, and to make sure that the data that we're getting is somewhat similar. I know Jen has been waiting for this, so I've specifically put this slide in here for her. As of today, we have banded over 138,000 birds on the island. So this number goes through the fall of last year. The 138,000 is through literally today, based on how many birds we've banded this year. Of those, almost a little bit over 15% are common yellowthroats, which is the picture shown in the top right. The second most common, magnolia warbler, almost half the number compared to the yellowthroats. The third most common, red-eyed vireo. And if you're interested in seeing some of the differences that we see, the birds are a little bit different between spring and fall. So I've done the top 10 most common species and the number that we have of each of them in this slide. Notice that in the spring, common yellowthroat, most common, we've banded over 16,000 of them. It is number 4 in the fall, but we've only banded about a quarter of the number in the fall compared to in the spring. The ones that are bolded and underlined are in both the spring and the fall, but they're different species between spring and fall. And that's not that surprising because of where we are located and what the habitats are. if we look at this slide, what I'm showing on the left-hand graph is, let me back up. The two graphs show the same thing. The blue lines are showing the number of species. The red lines are showing the number of individual birds. And the x-axis is the years from 1981 to 2021. So I've got, you'll notice at the very end, the line stops. There's a gap that's called COVID. And then we had the 1 year that we missed. And then there's the one dot from last year in each of the two things. So we've got spring, we've got fall. And what you will notice in the spring data is when you hit early 90s, we started seeing a bit of an increase. That's when I took over and started doing my master's and PhD research out here. And we started being out here on a pretty consistent basis. And yes, there's a lot of fluctuation, but we see pretty similar information, or pretty similar numbers of birds once we hit maybe 91, 92. If you look at the fall, the number of birds is dropping down, the number of species dropping down. Part of that is just simply we can't stay out as long as we could. And you're going to see a little bit later that migration is probably also changing a bit. In the spring, we're still able to get out here to be able to see all of that. Our effort in the spring, we have logged over 156,000 net hours. I just want to put that in perspective, the amount of effort that goes into some of this data. And on average, we're getting about twice as many birds in this per net hour in the spring as we get in the fall. And in the last 10 years, that number's only dropped a little bit. In the fall, that number's dropped a lot. So what we think about with Appledore, and this is one of the reasons that I was really excited about it, is most of the species we catch don't breed here. And that means that we know these birds are migrating through. We do have yellowthroats that breed here, but we do not have somewhere around 16,000 breeding common yellowthroats on this island. So, so we know that most of the birds that we're catching are migrants. And we know that these areas called stopover sites are really important for birds to avoid predators like the peregrine falcon on the left, avoiding bad weather like the let's go shut every window on the island storm rolling onto the island, or looking for food. And the bird that's in the bottom right is a summer tanager. It's not normally found this far north. I took this picture back in the day when you used film in cameras. Most of y'all in the room may never have used film in cameras. And I was using an Instamatic camera. So it was not something that had a super strong zoom. It was not something that I literally was maybe 6 or 7 feet away from the bird. And she allowed me to get that close because she had already metabolized some of her breast muscle and was using this island to feed to be able to successfully continue her migration. So one of the big questions is, why are birds stopping? Who is stopping? And how long are they staying on the island? And one of the things that I did early on was to look at some of the how Appledore might be different between spring and fall migration. And so we can talk about stopover sites as being either fire escapes, meaning it's absolutely necessary when you need it, but it doesn't really have any other normal function. You can't find food there. You can get out of a really bad situation, but it doesn't really help that much. A convenience store where you can find food, but it's not the best quality. You can maybe get something you need, but you don't stay there that long. Or a full service hotel where you can get everything you need. It's a great place to stay. You can find good meals. And so I started looking at the differences between spring and fall on Appledore. And one of the things that we found is that birds were much more likely to stick around on Appledore in the fall than they were in the spring. So in this graph on the x-axis, you're seeing a bunch of different species of migrant bird. On the y-axis, it's the percent of birds that were recaptured at least one day after initial capture. So they were staying overnight. Most of these birds migrate at night. So if we catch them on one day and we catch them on another day, they skip the potential migratory period. The yellow bars are fall, the green bars are spring, and notice that all the yellow bars are taller than the green bars. And the little asterisks are significant differences. Almost all of them had significantly more likely to be recaptured in the fall than in the spring. We also looked at how long they stay. And so in this case, I'm showing just minimum stopover. We've done some other work on modeling. But in this case, the bird was captured on day 2 of our banding season, on day 3, maybe not on 4, maybe on 5, maybe not on 6, on day 7. And so we're looking at the difference between 7 and 2, and we say this bird stayed for a minimum of 5 days. And if we compare fall versus spring, again, bunch of species on the x-axis, green is spring, yellow is fall. What you see is that most species were staying longer in the fall, more likely to stay, and if they stay, more likely to stick around for a longer period of time. We know that fat fuels migration. In order for birds to successfully move from one area to another, they build up fat. On the right, there's a chickadee. You can see kind of a hollow V where the breast muscle is kind of that pinky burgundy color. And on the right, you see a Blackpoll Warbler. And instead of seeing that hollow V, it's yellowish and kind of lumpy looking. That bird has a lot of fat. That fat is what is going to be what will help that bird migrate from one location to another. And we know that the birds are feeding to build up fat. They build up fat before they migrate, and they also build up fat during migration. The bird on the left is a black-throated green warbler. It has a fly in its mouth. One of the things I like to show there is I'm taking the picture, a fly flies by, and the bird eats it. A lot of people think, oh my gosh, what are you doing taking these pictures? You're not letting the bird forage. It will take advantage of whatever situation. A lot of people say, is it stress? It's, well, maybe that's stress eating, but yes, you will see that they are actually eating while they're going along. And then the bird on the right is an oven bird. And I use an oven bird because I have had multiple individuals, and this is not an exaggeration, multiple individual oven birds on this island that I caught on one day. We caught again 3, 4, 5 days later, and they gained 75% of their body mass. Think about going from 100 pounds to 175 pounds in 4 days. Now, I realize Eli's cooking's awesome, but that's, I mean, that is amazing. They're gaining all of this weight, and then they're losing the weight. And if you're looking at this, you might also want to know, really, what does that mean? We did some modeling, and I'm going to use the red-eyed vireo as the example here. If we captured the bird only once and we looked at what the average mass was, we looked at wing loading, all of that kind of thing, they can fly about 1,000 kilometers. If we looked at the birds that we caught, that we recaptured, many of them were lighter in weight when we caught them the first time. And so those would only be able to go maybe 750 kilometers. But if you looked at what they weighed when they left, so after they stayed for several days, maybe 3, 4, 5 days, they gained that whatever percentage of mass it was, and then they had added 400 kilometers of flight distance. Birds are able, when they are adding that mass, they are increasing their ability to fly longer distances and potentially successfully complete their migration. And so we looked at the mass differences between the birds that were captured, the birds that were captured, and then their last day of recapture. And in the spring, some birds lost weight. A few birds gained weight. In the fall, most birds were gaining weight. Most birds' mass was actually increasing in the fall compared to the spring. What this is saying is that Appledore may be more like a fire escape, or maybe a convenience store in the spring, depending on the species. And in the fall, it's acting much more like a full service hotel, someplace where they're getting a lot more of the resources that they need. The other thing that's really important to keep in mind, showing the two species that I showed with the importance of feeding, the black-throated green warbler and the ovenbird, notice where Appledore is relative to the breeding ground. In the spring, they're pretty close to their final destination. In the fall, they've still got a long way to go. And that may be making a difference in any decisions that the birds are making about what they're going to be doing in this location. Blackpoll warblers are one of the classic migrants. This is not my work, although we have published some work on Blackpoll warblers here. Recent geolocator work has shown something that for years we have had anecdotal evidence of, and we now have much better evidence that Blackpoll warblers that leave this island in the fall go out over the Atlantic Ocean and don't hit land again until they hit the northern coast of South America. And that can be somewhere between 60 and 100 hours of nonstop flight. And that fat is going to be absolutely essential for that bird to successfully make it out over the ocean. These are not pelagic birds. These are not birds that can just swim for a little while they're waiting. If they hit water, they're likely to not survive, going back into the difficulties of migration. A really cool project that was done out here by a master's student was looking to see whether the energetic condition of migrants would affect whether they stayed on the island or whether they decided to continue migrating. Using, again, this is a Blackpoll Warbler project, but this is what a female or a fall bird would look like. The lean birds, the birds that didn't have much mass, were very unlikely to fly away. The birds that had some fat on them, those were the birds that were more, that some would stay, some would fly. The ones that were fat, much more likely to leave. There was a field ornithology class sitting out there on Kiggin's deck, watching as Dr. Kristen Covino, who was not doctor at that time, was down in Broad Cove, putting the little bird with the glowing butt up above her head and figuring out the direction that the bird was going. And the ornithology class was saying, it's up, it's up, it's up, it's down, so that we could see whether the bird was leaving or whether the bird actually stayed aloft. It was an awesome experiment that she did that was connected to the banding station. We also had a master's student from the University of New Hampshire that came out and looked at Appledore, which is the largest of the islands, and Star, that's kind of the V-shaped one, more down towards the bottom. She ran a separate station on Star Island for 2 years for her master's project. And compared to Appledore, which is shown on the right, the Star Island vegetation on the left, there's much more open space. There's much lower vegetation. And what she found was that there were differences in the species that were likely to be on the 2 different islands. So things like Trails flycatchers, cedar waxwings, chats, black-throated green warblers, Wilson's warblers, and swamp sparrows were more likely to be on Star Island. Brown creepers, red-eyed vireos, Swainson's veeries, ovenbirds, black-throated blue warblers, and American redstarts were more likely to be on Appledore Island. And that we did not see, we really expected to have birds crossing between the islands. We were not catching birds that were banded from one island to the other island. Most of the birds stayed on the individual island where they were banded. Relatively recently, we've used some of our migration data to contribute to a project that Kristen and I were involved in, looking at a 50-year study of black-throated blue warbler migration. And what this was trying to do was to see how has migration changed over the last 50 years. A lot of people have heard that there might be some climate change occurring globally. And so one of the things we were interested in was whether this might be affecting the birds. Using bird banding data from a variety of different places, we looked at spring migration and we looked at fall migration. And what these graphs are on the right-hand side, I'm sorry, on the left-hand side, the spring migration ones, the first panel that has the lines on it is showing early migration. This is when do the first 5% of the birds show up. The middle panel is what's average migration. The bottom panel is when do the late birds show up. And if you see in spring, everybody's coming, it's definitely earlier for the early birds. It's definitely earlier for the peak migration. The late birds about the same, but at least it was not as significant as we had with the other 2 groups. In the fall, what we found is the earlier birds are coming earlier. Peak migration didn't change, and the late birds are coming later, meaning fall migration is getting longer. So when I said that we have a harder time in the fall on Appledore, not only are we leaving earlier, the birds are coming later. And so trying to get that on the island is very, very difficult for us to be able to do. We do see that males come before females. That's a very typical pattern in migration, but we see that over multiple years. And that's been what's kind of interesting about this. And we're now working on a project that's 6 decades using a whole bunch of different species of warblers to look at how migration might be plastic in groups of species. And we're working on a variety of things. The main thing that I wanted to point out here is that we have 46 sites that are doing spring migration. We have 124 sites that have done fall migration. This is using 2.8 million birds. Appledore has 6.25% of the warblers banded in spring migration in North America in the last 60 years. So I just want to point out why this island is so important. We really have been doing this research in a way that is allowing us to compare what we're doing to what we're finding at other locations. Very quickly, we've done some collaborations with the Maine Medical Center, looking at equine encephalitis and looking at Lyme disease. With Lyme disease is actually carried in ticks, in Borrelia, is found in some of the ticks that birds carry. We've done some work that showed that there's no deer. I think everybody has not seen deer on Appledore, right? So the ticks don't overwinter on this island. There's no final host for them here. And what we were able to show from Appledore data was how you could have recolonization of ticks into areas where you had not had them. Look to see how many birds were carrying them, how much of the spirochete that causes Lyme disease was in the ticks, how much of this might be transmitted. We also looked at the amount of variation in different strains of Lyme disease, indicating a fair amount of flow that's occurring there. If you've noticed, we have a wind turbine on the island. I want to point out that the bird banders are the reason the wind turbine was allowed to be put here, because the state of Maine was worried about potentially impacting seabirds that are nesting on this island. And so they said the bird people are going to have to check on the turbine and see whether they find any mortality. We did surveys every morning and every afternoon, every day that we ran the banding station for 6 years, and we found 0 dead birds. The state of Maine liked that. They said we could stop doing this. We did have a couple of cases where we thought there might be indication that obviously you can't see it's not a clear area. So we know we weren't getting every spot that might be there. But in all of the time that we did it, we only had a few indications that there might have been any mortality associated with the turbine. And as a research biologist, I can't do that much data without trying to figure out how we might actually be able to publish it. So I had a student who sat up there by the turbine and recorded every bird she saw to figure out whether the birds were flying above or below the blades, and were they close to the blades or further out. Most of the birds are just down below and kind of hanging out down below the turbine. It did not seem to be affecting their behavior much at all. And then on the island, for anybody who's out here now, you will see the group of people that are affectionately called Martians. They are doing our Mars research. That's the Mobile Avian Recording Studio. A couple of years ago, it's now been more than a decade ago, I went to a talk where they had just figured out all of the flight calls of North American warblers. They had gone out and been recording them as the birds were flying overhead or as they were released from a banding station. And as soon as I heard released from a banding station, my ears perked up. And so I went down and talked to the people at Powder Mill at the other banding station and said, would you be interested in collaborating? And the next thing I knew, we had started a project to see whether we could characterize flight calling behavior. And we started with the idea that birds would be more likely to give flight calls if they heard flight calls, and that birds would be more likely to respond to conspecifics, meaning the same species, than to other species of birds. And what we did was, well, we started off, I was going to build a box. The box sounded like a really great idea. And then we started realizing that the box had to be double walled, and that was going to be plywood, and that was going to be really heavy. And so we decided that it would be better to have a trailer. So I bought a trailer, and we put a double walled room in there with acoustic foam between the walls and on the inside of the wall. So there's 2 layers of acoustic foam throughout the trailer. A bird is suspended between microphones. We have a speaker on the floor. We play sounds to the bird, and then we record what the bird responds to us. And to make it more visible for us when we're actually evaluating the data, we also have in the right-hand corner down at the bottom, a microphone adjacent to a speaker without a bird, so that we can just see what we're playing compared to what the bird might be saying to us. We started off with 3 species of birds: a Blackpoll Warbler, a Magnolia Warbler, and a Yellow-Rumped Warbler. And then a spring peeper. I always wanted to be a herpetologist. If I wasn't an ornithologist, I never got to study marine mammals. So I kind of felt it was awesome to have a frog in a bird study. The idea of the spring peeper was, are birds responding because of a startle response? And so rather than do a metallic response, we wanted to give them another natural thing. It's a short call, very similar to, not similar in sound, but in terms of length, to the flight calls. And so we were interested in using that as kind of our control. And what we did was we started off with a recording that we would do where we put the bird in the chamber for 2 minutes. We would play sounds for 3 minutes, and then we would let the bird sit there for 2 minutes to see if it continued calling. This is one of those cases where if you haven't ever thought about it, how much impact are you having on the birds or whatever organism you're working with? After the first set of data, we realized we don't need to have them in there that long. They respond very quickly to the sound. So we went to 1 minute of acclimation, 2 minutes of playing sounds, and 1 minute of after the sound. And that's allowing us to get more birds through our system, but it also means we're keeping them out of the environment for less time. In this slide, what you're looking at is where we are. The bottom channel is at what we call our check channel. That's the one where we are playing the sounds. The top 4 are the microphones within our system. We were trying to do directional microphones, didn't really work, but we keep them because we have enough technological glitches that's useful to be able to choose which of the places we see the most. And in here, what I've got circled are where there is not a sound on the bottom and there is a sound in our chamber. So the birds are actually responding to the sounds that we're playing. I'm gonna see if this will play. All right, so what you're gonna see is this is a video of the video recording of us playing. Notice that the sound is in all 3 chambers. We've played it. Notice that there's a double sound. That first one, the bird responded up in the top 2. We played, the bird responded. Top 2 where it's not in the bottom. We played, and the bird called before we played again. So this is what we are doing, is going through, playing the sounds, recording the sounds that the birds are making, and then figuring out how much response the birds are giving. So the first question is, do the birds respond to do the birds call in that first 2 minute or later 1 minute period? We call that spontaneous calling. Without any cue, are they calling? Notice that it's around 2%, 2.5% for the Blackpolls, 1.6 in the Maggies, and 0.2 in the yellow-rumped warblers. Then we looked at how much are they responding to each of the calls. We played their own call, which is shown in the blue in the kind of diagonal line. And then the others are in white. So the Blackpoll Warbler responded 14% of the time to Blackpolls, 3.7 to Magnolia, and 0 to Yellow-rumped. The Magnolia, 41.9% to Blackpoll, 56.6 to Magnolia, and 10.2 to Yellow-rumped. So we see some pretty major differences. I love the spring peeper. The next to the last column, spring peeper 0, 1.9, 1.8. It's about the same as the spontaneous calling rate. So it was saying that it's not just a startle response. They really seem to be responding to the bird calls that they're hearing in this. And then we looked at, did they respond to their own calls, which is shown conspecific in blue, or did they respond to the other species, the heterospecifics, in black? And in all 3 species, they were far more likely to respond to their own species than they were to the other species. What I thought was particularly interesting is that middle column, middle row, the Magnolia Warbler. Look at the Blackpoll Warbler responding to Blackpoll, 14%. Magnolia Warbler responding to Blackpoll, 41%. They gave more calls than the Blackpolls did to their own species. So this led into how much variation do we have between species, some of the why might we have some more variation there, a variety of other studies that are going on. And so if you come down to the banding station right now, the 3 students from Canisius will be running the Mars trailer and tell you a little bit about some of the projects that they're working on. Just to make sure, this is where we could not get all of the audio technology to work out this way, but if you look at the structure of the Blackpoll call and the Magnolia call, they look very, very similar in overall structure, and they sound really similar. The yellow-rumped call is very different, and you can see how it kind of looks like it angles upward a little bit. And so that may be part of that difference, is the similarity in sound between the different species. We did find huge differences between the likelihood of responding by different species. So we've been working with 8 different species on conspecific calling to see what percentage of birds are responding, and then using some of the species that are most likely to respond to ask a variety of other questions as we move forward. So the first one was, did they call? The second one is, how many times do they call? We've done, some birds only call once or twice. Some birds call we've had some that have been 60 or 70 times during the 2 minutes of the recording. So as our research out here continues, we will add projects. I didn't go through all of the projects. We actually have a variety of other projects that are going on. We don't know what other projects will come up. I think we've done some really interesting work on things that randomly came about, or people that have said, hey, we would like to collaborate. And we expect that we will continue to see things as y'all contribute, the people here in the room, to different pieces of different questions that you might have that spark something, or that are helping out with some of the work that Dr. Covino is doing with her LMU students, or here with Shoals students, or some of the banding data that we have. We have a lot of collaborators who've been involved in all of these projects. And so I do want to recognize all of them. Powder Mill was been really important in terms of the flight calling. University of New Hampshire has been awesome to me as a researcher. Shoals and Cornell together giving us a lot of resources to be able to come to the island. Braddock Bay Bird Observatory, Maine Medical Center, Colorado State is where one of Kristen Covino's and my collaborators working on some of the long-term data sets are. Loyola Marymount is where Kristen is now, and then of course Canisius College. I have an amazing group of volunteers. We run every spring, we run for about 5 weeks. Every fall we run for 4 to 5 weeks. And that only works because I have a wonderful group of people that will band the birds, that will take birds out of nets, that will help do all of the chores that we have to do to keep everything up. And they still smile despite working from before sunrise to after sunset. They smile most of the time. And then I can't end a talk without thanking everyone from Shoals, because if you can see it, this is the Kingsbury, which is not out here right now, but on the back of the Kingsbury on the left, that's my trailer. They loaded my trailer onto the Kingsbury. And then my favorite picture ever is the one in the bottom right. That is 3 engineers staring at the other engineer, taking the trailer off of the back of the Kingsbury with the backhoe. And they were so happy that I had not told them anything that was in the trailer before they started doing this. They got really nervous about everything afterwards. So the trailer's not leaving. That trailer is on this island. But the engineers have always helped us. Last year, I needed something. I needed a lighter, and Roger gave me a blowtorch. Anybody who gives me a blowtorch is a good guy in my case. But it's also, it's a group of people that have really helped us answer how, when you're on an island, you can't just run to Target and grab something. How do we make something work? We've run into this little problem, and the island coordinators, the lab preparators, the students, faculty, anybody, the engineers, cooks, anybody out here has helped us with coming up with better ways of doing things that have allowed us to do all of the different projects that we've been able to do. And with that, I think I'm good in terms of my time for questions.
Great. So please fire away, and I'll let you know if any come up here.
Yes.
So you were talking about the spontaneous calling.
Mhm.
What are the permits for them not to do that? So, like, why?
All right, so that's a much bigger question. So the question was, when I was talking about spontaneous calling, why might they do that? What might cause them to do that? So the whole idea of spontaneous calling is that they are not calling to a queue. They are calling because they're calling. Honestly, I think that, and this is a big thing. Let me back up. I really, really, really can't wait until we get miniaturized little devices that will allow me to put a sound recorder on a free-flying bird that will let me, and then, like upload it to a satellite so that I can get the information and don't have to recapture it, so we can answer some of these questions. But what I think may be happening is a couple of things. One is, if a bird is flying, they may be calling to kind of, is anybody else out there? Right. So you will hear zips and seeps overnight where the birds are just calling as they're going over. Are there birds? What are the winds like at different levels? Don't know. What are the, is there anybody else migrating? Or what's happening here? And then at the end of migration, because they actually call more in the morning than they do at night, which is crazy, but we've just shown that with an experiment done at Braddock Bay. they may be using it for habitat selection. So calling out and then calling to see whether someone responds. And if the someone is their species, that may be telling them this is a good place for a Blackpoll warbler. Nobody stops. And that may be part of the reason why Blackpoll warblers don't call much and they don't respond much, because you can't land in the middle of the ocean. And so that would be a bad thing for them to cue in on. But for many of the other species, it may be something where it's helping them in terms of habitat selection at the end of a nocturnal flight, before they can necessarily do good evaluation of what is the habitat on Appledore, because they'll stop, I don't know, 2, 3 o'clock in the morning. They're not seeing what Appledore looks like at that point. They may be listening to who else is here. And if they hear their species, that may be a good place for them to stop. That was way longer than that question, but thank you for asking it. Yes.
So you mentioned elevated mortality rates among adult birds during the migration. I was wondering if you could break that down a little bit as far as sources of mortality. Like, are they like getting lost over the ocean? Are they hitting windows?
Okay, great question. So the question is, could we break down the sources of mortality during migration for birds? And the short answer is no. The longer answer is, we know that there are a bunch of different sources of mortality. So we know windows, for example, are a massive source of mortality. We know that guy wires for television and cell towers are a massive source of mortality on days when the cloud cover is low. So only if it's very cloudy and the cloud cover is low, and the birds will actually run into the guy wires. They'll see the tower, but they won't necessarily see the cables that are keeping it upright. Windows, we know that lights can cause disorientation. Birds can end up flying into windows, not knowing that there's something there. Although most birds are migrating high enough that they're outside of running specifically into windows, but then they stop during the day and they're foraging and there's windows all over the place. There's cats all over the place. No offense to anybody who's a cat lover, because I know keep your cats indoors, all's good. Better for the cat, better for the birds. We know that there's predators. There are species of falcons in the Mediterranean. When do most birds breed? Sorry, I'm asking a question now. And I'm asking it to the ornithology students that are in the room that are looking very confused because it's day 1 of ornithology. So most birds, okay, let me ask you this. Are there breeding birds on the island now? Yes. Thank you. You're seeing some baby birds around the island, right? So the baby ducklings, the eider ducks, maybe, and maybe some of the geese. Okay. There are most birds in North America, and this is, not that far off in terms of the latitudes. Most birds in North America are breeding during the summer months, and then during the fall months, that's when the young birds are on their own. There are falcons in a little bit southern compared to this, but almost the same kind of latitude, maybe not as Maine, but as the eastern United States, that breed in the fall. And they breed in the fall because their chicks become independent when all of the young migrants are now available to be eaten. And so the poor baby migrants that are, independent are now falcon food for the young falcons that are not good at catching things yet, but are better at catching things that aren't really good at getting away from falcons that the young birds might be. So you see a tremendous amount of different sources of mortality, different species, different locations. A lot of birds, bad weather. So as climate change is occurring, it's not just affecting, okay, it's warmer in the spring, the spring starts earlier. It's also more of the massive storms that we've seen over the last 10 years in North America. More massive storms, more dead birds. And many of those massive storms, spring and fall migration. So so unfortunately, there's not a good way to break that down, because a lot of this is how many birds show back up during the breeding season. We don't know exactly what caused them to not make it back. We just know that most of the difference occurs during the migratory seasons.
Thank you.
Sure. Again, long answers. Yes. Great question. There's a lot of, there are multiple different ways that they are queuing in. We know that birds are using a stellar compass, meaning using the star. Sorry, how do birds know where they're orienting? How do they know where they're going to go? And I need to, gotcha. I'm sorry, I'm really bad about, I can't see anything here other than my slides. So how do they know where they go? How do they know how to orient? So for the songbirds, and I'm going to stick with songbirds right now because that's most of what we've talked about. They're queuing in on a variety of different things. We know that they have a stellar compass. They can actually see the rotation of the night sky and determine orientation and head in the right way. They combine a map sense with a compass sense. So that's the true navigation, whereas they will learn where they're going to be going and queuing in. They have the ability to queue into the magnetic field of the Earth. They have the ability, and we actually believe that that is being mediated by some of the cones in their eyes. Now, I'm not saying they see the magnetic field, but in some way they are detecting it based on part of their visual system, which is just crazy. Some birds are actually hearing infrasound or low level sound that may be kind of, if you think about the coastline where waves are hitting, apparently there's some of that. Some birds are using, if they're migrating during the day, most of my birds, most of the songbirds are migrating at night, but some of them do migrate like the Blackpoll Warbler, both night and day. Others like cedar waxwings migrate more during the day than at night. And they can queue in based on landmarks that they see. So there's a whole bunch of different things. What's really crazy, the parents feed the babies, get them to be slightly larger than the parents themselves are, and then abandon them. And these birds find their way based on cues that are in some way genetically pre-programmed and innate kind of behavior. In many cases, we believe that has to do with the amount of migratory activity that they feel, or the amount of restlessness that they go through during the spring and fall that will get them to approximately the right place. And whether flight calls are used for some of this as well, I don't know, but that's a possibility. Yes.
Your findings showed that the number of birds you banded was higher in the fall than in the spring, right? Was that
Other way, more birds in the spring than the fall.
Is there like another site that we have data for that shows it's reversed there, showing that you're taking the other way around? So
there are very few locations that are doing both spring and fall banding in long-term studies. I mentioned that there are like 50 sites for the spring and 124 for the fall. And so we do have some like Long Point, Manomet, Powder Mill that are doing things. I don't have access to all of their data to have done an analysis like I did for Appledore. And you would need to know more about their effort. And so when we do certain types of studies, we don't necessarily have to know all of their effort to be able to combine data from different locations and that kind of thing. But without having effort data, you don't know whether something is because they're not studying it the same way that they were before or what have you. I will say that in Ohio, the Black Swamp Bird Observatory is the one that has the most spring migrants. In the fall, I think the largest is like 3%. So I said Appledore has 6.25% of spring migrants over all that time. The largest one in the fall is like 3%. And then most of us, Appledore is under 1% because all of these different sites have so many different birds that are there. So it would take a little bit more data than we have to answer that question.
Can I ask a clarifying question? The 6.25% of
so the question was the 6.25% is what? From 1960 until 2018, warblers banded in North America in the spring. Appledore has 6.28% of all warblers banded in spring migration in North America since 1960. So that's why spring is like our bread and butter, and why I regularly harass people at Shoals to say, can we get out any earlier? Yes.
This isn't really like your research, but it's much at the beginning. But how was your fine arts major?
Okay, so the question is, at the very beginning, it was mentioned that I have a fine arts major. How does that fit in? I'm going to tell you 3 different things. The first one is I'm very comfortable. Jen, when did you ask me to do this talk?
Like 2 days ago.
So you know, I kind of get up and I've learned how I took a class in voice and diction so that I could speak better when I was going to be a college professor. I can still say, what a to do to die today at a minute or two to two. A thing distinctly hard to say and harder still to do. For there'll be the tattoo at 20 to 2, a rat-a-tat-tat-tat-tat-tat-2, and the dragon will come when he hears the drum at a minute or two to two today, at a minute or two to two. Everybody should do that, right? Thank you, thank you. So, so voice and diction was a big one. One was my faculty advisor said, you should do something fun. You're doing all biology and it's kind of, you know, it's intense. And so I got to do that. And then the most important thing, I got to play with power tools. And so it was, I loved doing set design and set building. And so yes, Mary kept my fingers on while I was out here, but it was not my first rodeo with a table saw. So, you know, it's kind of the, how do you do that? But yes, I thoroughly enjoy, and actually there are a bunch of theater majors that are also biology majors. And part of that is, I think you have to be very creative to be a biologist. You have to be very creative to be in the theater. And I'm sorry, biolab and theater lab have an awful lot in common. Very experiential.
All right, thank you so much, Sarah. Thanks again.
Thank you.
Okay, if you want to prove to yourself how close theater and biology are, please Google Les Mis, or maybe Mary knows where this is right away. You'll find a gull version of Les Mis. That was exciting. All right, everyone. Well, thank you so much for sticking around and staying tuned. Next week, Dr. Larry Alade is from the Northeast Fisheries Science Center, which is a NOAA institution down in Massachusetts. He does fisheries stock assessments and helps make management decisions. He's going to be our speaker next week, same time, same place. All of the information about all of our speakers, and for some of you, this might be interesting for you to look at. For the last couple of years, all online on our website under the Shoals live stream. All of them are recorded there. Maybe find another bird talk there. I'm just saying. All right. Have a good night, everyone. Thank you.
Give me just a second.